Yes, vaping is a green practices. Is better than smoker, everybody knows.
The first conclusion is that vaping is safer than smoking tobacco cigarettes, of course.
I would say that it does not make sense to stay a smoker once you have the solution of vaping product.
I'm 𝗬𝗂𝗀𝗍. I'm the co-founder of VDLV and Ingésciences company with Vincent, my associate. We installed here actually in this building in 2019, and we changed the name LFL to Ingésciences because Ingésciences work a lot of engineering and research and development analysis. It's a new start for us because actually we are really with the space we need, and it's better for business, it's better for ambition, of course.
All right, so of course Phil showed you all the production and how we make nicotine out of a tobacco leaf. We make wonderful flavors, millions of bottles go out, but science is very important. Science is something, unfortunately, this industry does not take as seriously as they do here in VDLV. So here we are in the laboratory area. It's basically broken down into 3 different sections, correct?
Yes, and here we are at the Ingésciences laboratory. Ingésciences is like a sister with VDLV, but we invest a maximum of energy to produce scientist reflection and to push innovation and observe the impact of the vaping practices on vapors, etc. So here we are inside this laboratory, and we have 3 parts of this laboratory: the analysis of physical parameter, chemical parameter, and biology impact.
This is more of the mechanical aspect of vaping. As you can see, they have developed their own machines, their own vapor machines that can extract vapor for emissions. They actually have their own machines to test the mechanical aspect of vaping. Why is that important? Well, you heard, the study that's happening in America where they were, using the wrong device at the wrong voltage. It doesn't really reflect how a user uses a vapor product during the day. They can actually replicate here exactly different styles of vaping, draws, wattages. They're never going to have that issue of burnt coils like we're seeing in other studies as well too. So the physical parameters of vaping are just as important as what you're going to get out of the emissions or what you're going to get out of the e-liquid testing, right?
Exactly, and we produced in 2016 this machine, the USAVE, Universal System for Analysis Vaping. Exactly, the machine can reproduce exactly the vaping practices, and we create a cryogenic trap for extracting perfectly the emission, and after we can analyze the condensates of this trapping, and we can analyze the liquid before and after vaporization, and we verify if there is byproduct emission, if the performance of the vaporization is correct. Every parameter are analyzed here.
This is a really interesting fact. This machine right here can actually capture passive vaping, like second-hand vaping as we hear in America. So they actually had this machine at the Vapexpo Paris. We were just this past weekend, and the analysts here will take all the data and tell us exactly, you know, what we get in secondhand vapor. So really interesting to see that.
For us, it's very important to prove when we produce a chemical analysis to put like a layer the physical parameter. If you burn the chicken when you're cooking, the chicken is not good, and you don't eat the chicken. Actually, in vaping analysis, sometimes scientists don't produce the physical parameter in front of the chemical analysis. That's a problem. It's the reason that we create all of this system, all of this machine. We produce this machine for that, is to be really correct and to put vaping in real practices.
Now we're in the second part of the laboratory here, and you know, you've probably seen a lot of the videos me and Phil have done, and you might recognize some of these machines. Of course, what is this department?
It's our chemical laboratory. We have some HPLC, UPLC, chromatography, and these equipments are be able to make analysis, spatial analysis. In this place, we have analysis for byproduct generation, like for maldehyde, acetaldehyde, etc.
Acrolein, some of the stuff that we've seen.
Here we analyze the spectrum of the flavors, the spectrum of the flavor. It's for verify if the flavor we selected are correct for inhalation. And in this machine, it's the production of VDLV, and this machine are working and running every time 24 hours by day, because we analysis in VDLV more than 2,000 analyses per month. It's for verifying our production every time.
You know what I find interesting, Phil, is, you know, when we first met Charlie, we, you know, started taking a tour yesterday. You know, we saw the big PBusardo, you know, containers, and the first thing that Charlie said is that, hey, you know, before the truck comes in and starts loading this, we take a little sample, and it comes up here in this space right here. They check, make sure that the specs that the company has required from the supplier of PBusardo meet the specs that are being delivered before it's entered into the gas. So all that's checked first. The same thing with the aromas, right? Flavor molecules. They have their own standards. They want some molecules, they don't want some molecules in flavor. When the flavors come inside here, they put them in the machines, they test them to make sure that they're up to standards for the company to produce the liquid. And that just goes across everything you do, right? I mean, this is one way of you to do quality control, not only on your suppliers, but on your company as well too.
Yes, and we're certified by the AFNOR. It's the French agency for standards, and we can prove that what we say we can verify, and we do the maximum for the safety of vapor.
You know, how many times have we said, you know, you look at a label of the bottle, e-liquid, it says something on there, but can they actually tell you what's inside that liquid? Well, I guarantee you, they can tell you what's in that bottle of liquid you're going to buy from here. Now, third department here, Charlie, what are we doing here?
Here we are in the biologic laboratory. For us, it's a really important strategy, because we have to verify the impact of the vaping behaviors on cells, on human cells, and we create for that a spatial incubator for analysis this impact. And we plug a vaping machine, the 𝗖𝗟𝗧 machine, and we can prove the generation of emission perfectly. And we put inside the liquid, a standard liquid, for example, and we verify the impact on cells with the working on the microscope and the life of the cells with this generation emission.
Yesterday, Charlie was showing me this is one of the 3D models that they have printed here. They can layer the cells actually into this mold, and then they can pump the vapor through these cells, and they can do it layer. It can be just one, or they can actually replicate part of your lungs, so some of the cell tissues that build up to make one of the walls in your lung as well too. And what you're seeing right there on that screen is where they're analyzing those cells after the vapor comes in, which is very, very important. Again, going back to what we said earlier, a lot of the scientists and the science that we're seeing, especially coming out of America, don't do this, right? We can't get actual results unless we use actual use of the product. Which brings us to this triangle that you talk about, this triangle all the time. So explain to us what this triangle is.
This triangle is the perfect equation for vaping, because there is behaviors, there is the liquids, and the devices. And every time this triangle is like a link. If you modify one parameter, the impact is not the same on the cell, for example, or on the device. And we have to explain to public and explain to institution that if we perfectly control all of these parameters, the conclusion can be correct, can be real, and we want to produce real vaping here for real conclusion.
So if you think about it like just in that triangle sense, we start with the physical parameters inside there. We'll make sure that we're accurate as far as, you know, the wattage and the pressure and how the draw of the vapor is. All starts in that room. Then all that emissions in the liquid is verified in the other room to make sure everything is correct. And from there, we take that liquid and that vapor and we apply it to cells and see that to complete that complete triangle. It's extremely important to note, right, that usually in this triangle, in most studies, we're missing the one,
yes,
the behavior, right?
Exactly.
Yeah, that's very. We can take liquid off the market and test it. We can actually take emissions and test it, but does that really represent how, we don't drink liquid, we vaporize liquid into our lungs, right? So that third part is extremely important, and that's what we're seeing that they're replicating here.
Yes, and for us, it's important to prove our method, because the time actually is to make place, we have to make place to the university searcher, because we don't want to prove to me, but to scientists.
Correct.
And this is a perfect tools, perfect place for university research.
So Charlie, let me ask you a question. We have great business, big business, many bottles, nicotine. To you as a person, how important is that you have full confidence in the product that you produce for people to inhale in their lungs?
Yes, vaping is a green practices. Is better than smoker, everybody knows. But we have to prove how many percent is better than pure air. Of course, the impact of the selection of the molecule is very important. We are very responsible because we don't eat, we inhale. In a few minutes, if there is a problem, it can be a problem for everybody, and we've seen in USA the impact of this accidents. If standards are correctly programmed, if the practices, the professional practices are okay, vaping is the future and the clean future.
I challenge all the companies across the world, especially here in France, to join into this project. I think that's the only way that we can change the perception of vaping and show to those that want to eliminate vaping is that vaping is much less harmful than smoking. And the only way to do that is with science.
Science and scientists.
This lab consists of 15 people, staff, but here we have, introduce yourself.
My name is Sébastien. I am a researcher in Ingésciences since 6 years now, and I just ended a PhD.
So tell us a little bit about the work that you have been tasked to do here from the owners.
Yeah, the aim was to provide some physical sense into vaping product, because most of research miss some physical understanding, and the aim of my PhD was to provide this knowledge, which is really missing in most of the research we have currently done.
Part of doing your PhD was to show that, hey, look, we have all these studies out there on vaping, but really they haven't taken the physical parameter into consideration before they publish a study.
Yep.
And that was part of what you were trying to prove, and you actually proved it into your PhD.
Yeah, exactly.
How do we take this to the next level, right? We saw that some of these studies that are out there are, I would say, not complete, not to offend any scientist, of course.
Now, most of the job I've done is published into my reports, and now the aim is to publish many papers which provide the results and the conclusion into the physics and the scientific journal. And doing so, we will begin to improve and to introduce physical sense into the vaping research. And once it will be done, the next step will be to to highlight that the physical phenomena and the physical sense I am trying to explain leads to chemical conclusions and to biological conclusions. It's like a story. Once you activate the battery, the main phenomena is you vaporize the liquid. So it's begin by air, and then we will move to chemical conclusion, to biological conclusion. It's like
I think ultimately the goal, and to translate a little bit into something more easy to understand.
Yeah.
I think if we by publishing studies using all of the criteria and the physical parameters that they create here in the laboratory, I think not only does it help the industry, but it also helps other scientists as well too, to give them a protocol, give them a threshold of where they can start their studies as well too, which is extremely needed now.
Yeah.
So by publishing these studies, not only are you helping for your own research, you're actually helping other scientists as well too, because really we don't really have anything like that out there right now.
And then the aim is to improve the protocol and to introduce some physical sense into standardization also, because currently there is some protocol which are mainly coming from tobacco companies, which are very simple and adapted from what is currently done into smoking research. But a cigarette is not like vaping. The physical phenomena is not the same, so the protocol could not be the same, and there is some new protocols that should be created, because
based on the variables of the different styles of vaping, the different liquids, mouth to lung, direct lung, there's just so many variables. So let me ask you, what do you think is the #1 error? I mean, I'm sure you've gone through all the studies, you've seen everything that is out there, and especially for us in America, I mean, we're just getting killed daily on vaping. What is the #1 error, mistake that you have seen? Or maybe, I shouldn't say error, because again, scientists, they take it very personal when you say that they made a mistake. But maybe what misunderstanding we've seen in the previous study?
In my sense, the main one is direct lung versus mouth to lung. It's the key, because when you use direct lung into the device, which is made for direct lung, 𝗧𝗵𝗶𝘀 device, the airflow is here to cool the system. And because the system is mainly something which allow you to generate more vapor, you will have to have a system which cools the system sufficiently to maintain the device into good condition. So if you use a mouth to lung regime on a device intended for 𝗧𝗵𝗶𝘀 device, it's like if you want to light off a fire into a wood just by
just blowing it like this. Yes, exactly. I understand.
It does not make any sense.
So they're using the wrong machine to capture direct lung vaping, for example, but the coil gets too hot. So whatever emissions you're going to get are not going to be accurate, pretty much. And also machines that can capture the volume. I think one of the scientists told me usually when you mouth to lung, you capture about 75 ml of vapor in your lung, but when you direct lung, you capture 400 mLs of vapor into your lung. So you actually have to develop the machines to be able to capture that quantity of vapor as well too.
But it's also a problem which comes from tobacco companies, because most of the machines which are currently used in labs come from
cigarettes.
Yeah, exactly. And so the protocol and the design of the machine is mainly done for a mouth to lung regime, and it's the main error, because if you say that it's not my problem because the machine is currently done for like this, and I can't update my machine, you will automatically provide some bad results.
I saw one study about 2 months ago that was done. They used a 𝗧𝗵𝗶𝘀 tank and they put 50 milligram salt nicotine inside. The scientists, real use, this does not happen. People do not use high nicotine salt with 𝗧𝗵𝗶𝘀 tanks at 80 watts. You cannot even vape it. Physically, you cannot vape it. But a study was done like that. It's just mind blowing.
And the problem with direct lung is mouth to lung is reveals a bigger problem, which is the consistency of the laboratory experiment, which are not consistent with real use. And because you miss this, you miss a lot of information, because For example, if you have an experiment in which the cotton is burning, vaping machine can't smell, they can't feel.
Sense that, yeah.
And you will continue, and at the end you will have an experiment which will not be consistent with real life,
real-time use.
Because users feel burning taste and they stop automatically to vapes, and they change the device and they vape with a new product.
Yeah. So tell me specifically now here, what are you working on right now? The main focus of your research right now.
The main focus is the consequence of the physical problem of boiling into a device.
Yeah.
The consequences in terms of chemical degradation, which shows the key, because if you have an idea of what is product in terms of byproduct, and if you have the limit, you could say the risk. You could assess a risk assessment which is coherent with real use, because now you will see in main publications that people use some chemical analysis to realize their risk assessment. For example, people could do a risk assessment with a low production of byproduct and also with high production of byproducts. So the conclusion will not be the same because the risk will not be the same. My aim is to say that between these 2 points there is a physical limit, which is feelable by the user, and once you pass this limit, the risk is of course increased because you're in overheating condition.
Right. So again, to explain a little bit more, there's different levels of vaping, you know, whether it's MTL, direct lung vaping, RDL vaping. However, by doing testing, you find what that ideal range is. So the consumer can be educated and say, between this range and this range, we feel like this is the best possible scenario for that type of vaping. But once you cross that threshold, some of the properties, some of the byproducts, you know, some of the formaldehyde perhaps might increase, and this is the level that it's going to increase, and consumers should be aware of that.
The key is really to define the power range, because there is an optimal power range between which the risk for the consumer is significantly lower than
minimum.
And once you have this power range, the risk assessment could be coherent, could be consistent with real use.
There's one question that we always ask scientists every time we talk to them. So, in everything that you have seen in your work, you've been working, 6-7 years in the vaping industry. All the research that you have done yourself, all the other research that you have. Is there any reason a smoker today that they should not switch to vaping if they have tried everything else and have failed?
No. The risk is significantly lower, and there is no question. There is no problem. The problem could be if you ask to someone which is not smoker to vape. Does not make any sense. But for a smoker, I would say that it does not make sense to stay a smoker once you have the solution of vaping product.
Well, thank you very much for talking to us, and we're very excited to see the future work that's going to come out of this laboratory. Not only for the products and what you're producing here, but for the improvement of the entire industry. That we desperately need that.
I think the chance for vaping industry is that we want to improve the quality, and we are aware of vaping product, and the conclusion we wanted to highlight is that the risk and the use of vaping product is a solution for the tobacco problem, the smoking problem. So if you accept that this is a solution, our role is to define the limit and the healthier way to use vaping product.
All right, look at that. More lab coats over here, more scientists, more research work. Introduce yourself.
So I'm Jeremy. I'm an analytical engineer here in Ingésciences, and I'm working on analyze vaping products and their emissions too.
Isn't that the most important part, right? The emissions of a vapor product, isn't it? Because that's just what we inhale into our lungs. So talk a little bit about the work that you're doing here.
The aim of our work is to analyze the chemical composition of the emissions and also the impact on human health, and both on short term and long term.
Yeah, so tell us a little bit what you have found so far. What are some of the conclusions that you have come out?
So the first conclusion is that vaping is safer than smoking tobacco cigarettes, of course, but also there is some practice that should be not regulated, but firstly looked. Yeah. And secondly, yes, we need to reflect about it. And to educate both professionals and consumers.
Yeah, I think that the consumer, when I look at a bottle of wine or I look at a bottle of water and it's sealed, it has the label on, I never think to myself, where they make this. I assume as a consumer the bottle of water is safe. I assume the bottle of wine, it's all made, with some standardized practice. But that's not the case in liquid, right? Because we don't have a really standardized practice yet, especially across, a global level.
On vaping products today, there is no obligations to the manufacturers to test their products. Correct. So in there, we offer solutions to the manufacturers to analyze their products and optimize the chemical composition in order to make it in a good way.
When we're talking about a composition of a liquid, we're looking at a lot of chemicals, right? And part of your job is to see, what molecules we need to remove, what flavorings maybe we need to remove, correct? So talk a little bit about that process of how you guys determine in the composition of a final product that the consumer gets.
Yeah. So to do that, we start from the raw material, sorry.
The raw material,
yes. And then flavors, and we look like an ID of the raw materials. So a flavor can be composed by around 10 or 20 compounds to more than 100. So it's a big job to firstly identify the chemical composition, then research on toxicological aspects compound by compound. And after that we have beneficial risk balance that we have applied on our raw material to choose which one will be used in the final product.
Correct. We always say it's not the poison, but it's the dose, right? There's some acceptable level on everything, and I found that really interesting. We were having again, the 𝗍𝗫𝗨, the big D word again yesterday discussion. You would think, we wouldn't have to talk about it today, but that is one of the components that you look for in the allowable level based on the amount that's being used in the liquid.
On 𝗍𝗫𝗨, you know that it's okay with ingestion, and it's not okay with inhalation.
With inhalation,
this coming from occupational work in the US.
Work, yes.
And so in France, in the French standard on liquid production, there is a limit coming from the US work.
Correct.
And so one of our mission here in the lab is to measure the 𝗍𝗫𝗨 level in the raw material, and so we can create a maximal concentration of our raw material in the final product to respect
not to supersede that allowable limit.
Exactly.
Correct. It was really interesting when we were talking yesterday how you're literally going through all the flavorings that you're using here for the production of your e-liquid to identify all the compounds inside. This is a huge task that you're undertaking, right? Talk a little bit about that progress of you checking all these flavors.
Based on the chemical diversity that we are based on the chemical diversity of flavors, we need to advance step by step. So the first years we were looking for the main compounds, main as the more concentrated compounds and also the more frequently used components. So and year by year we extend our knowledge and our works on the majority of the compounds, the flavor components that is used in the vaping products.
And these flavors are used by a lot of manufacturers, right? They've been around commercially for a very long time, but it's very important to kind of like distinct the flavorings that are actually used for inhalation or for vaping than other flavorings that are used for.
The aim, the final aim of our work is to create. We called it here. We called it vapology grade flavors.
Vapology grade, yes, we understand that. Yeah,
products dedicated to our
industry.
Exactly. So this is the final aim, and so we need to work with flavors manufacturers. Health agency, governmental health agency, to help us. They need to help us to do this work because it's needed for the vaping, and so I'm really happy to do my job.
I bet you are.
This product to develop.
We're very happy to see the results. For you personally, the work that you take. I mean, obviously you take your work very, very serious, and we ask this to everybody. All the work that you have seen, all the analysis that you have done. Is there any reason anybody that smokes today, in 2021, is there any reason? If they have tried patch and the gum and they can't quit smoking, is there any reason they should not try vaping?
For me, no. There is no risk. No.
Simple.
There is no reason.
Simple like that. No reason at all. Why are you still smoking? It's 2021.
That's good.
All right. Well, thank you so much for your work. Thank you for your hospitality here. And we look forward to, me and Phil, and of course, all the industry looks forward to your continued research and results, as we are so much interested in having vaping around for smokers.
Thank you very much.
Yes, vaping is a green practices. Is better than smoker, everybody knows.
The first conclusion is that vaping is safer than smoking tobacco cigarettes, of course.
I would say that it does not make sense to stay a smoker once you have the solution of vaping product.